Okay, today we're going over 6.8, the binomial theorem. So let's take a look at a binomial, such as a plus b. A binomial is two terms, and let's take that to the 0 power. Anything to the 0 power is a 1. So we're going to also write down the coefficients that we get here after we expand some of these. If we take this binomial, a plus b to the first, then that's just a plus b. Okay, if we take a plus b squared, then that's a plus b times a plus b, and therefore we get a squared. We will FOIL this out. We'll go first is a squared, the outer is a times b, the inner is ab, so that's a 2ab, and then the last is b squared. And let's also do a plus b to the third. So this is when it starts to get a little long to multiply all of this out. So this will be a plus b times a plus b times a plus b, because there's 3 of them. So we already know that a plus b times a plus b, we did that right here, is a squared plus 2ab plus b squared. And then we'll bring down the other a plus b that we have. And if I distribute a to every term and I distribute the b to every term, then I'll come out with a cubed plus 3a squared b plus 3ab squared plus b cubed. So if we look at the coefficients that we're getting here, the coefficient is 1 here. The coefficients here, which are the numbers in front of the variables, are 1 and 1. The coefficients here are 1, a 2, and a 1. The coefficients for the cube, there is 1, 3, 3, 1. And this is the start of Pascal's triangle. So Pascal's triangle is taking the coefficients and it's going to help us expand it rather than multiplying all of these out so many times. So for Pascal's triangle, to get the numbers, you start with a 1, and then to get the other numbers, you're going to add the 2 above it. So 1 plus 1 is a 2. The first and the last numbers are always a 1. 1 plus 2 is a 3. 2 plus 1 is a 3. So the next row will be 1. 1 plus 3 is a 4. 3 plus 3 is 6. 3 plus 1 is 4. And so on. 1, 5, 10, 10, 5, and 1. And we'll just do one more row. 1, 6, 15, 20, 15, 6, and 1. And these are the coefficients that you'll get when you're expanding a binomial. So let's try and do an example of one. So let's try to expand a plus b to the 6th power. So if it's to the 6th power, we're going to use that last row that we wrote down, which are going to give us the numbers of 1, 6, 15, 20, 15, 6, and 1. And these, which are from the Pascal's triangle, are going to be our coefficients for when we expand this. So what we're going to do is we're going to make a little box and then 2 sets of parentheses for when we're expanding it. If we count how many numbers we have here, there are 7 numbers, and there's always going to be one more than the number you're expanding it to, or the exponent. So there's going to be 7 terms in total after we expand this whole thing. So that's 1, 2, 3, 4, 5, 6, and 7. It's hard to fit it all on there, but we did it. Okay, so now we're just going to put these numbers in. So we'll put the numbers in as 1, 6, 15, 20, 15, 6, and a 1. And then what we're going to do is we're going to start out with the highest number, the highest value. So this will always have an A in it. And then we're going to start this first term off with, this will always start with the highest exponent, which is the 6, because we're going to the 6th power. So this will be a to the 6th, then a to the 5th, a to the 4th, a cubed, a squared, a to the 1st, and a to the 0. Then we'll do it for the b, and b will start with the lowest. Start with the lowest exponent, which is always going to be 0. And then you go to your highest, which is whatever you're expanding it to. So b to the 0, b to the 1st, b squared, b to the 3rd, b to the 4th, b to the 5th, and b to the 6th. And then we can just clean this up a little bit. So if we're looking at these here, we can write them as, writing them all out, a to the 6 is just a to the 6th, b to the 0, anything to the 0 is 1, so that won't affect it. We have a 6, a to the 5th, b to the 1st, but we don't have to write the 1st, so we'll just write a b. We have a 15, a to the 4th, b squared. We have a 20, a cubed, b cubed. 15, a squared, b to the 4th. 6a, b to the 5th. And finally, a to the 0 is 1. And then we just have a b to the 6th. And that is our answer for when this is expanded. So if we go a step further with this, we can also use combinations. So when we're using Pascal's triangle, we know that I can write this using combinations here. So the combinations for this is going to be whatever you're expanding it to, which in this case is to the 6th, that will be your first number. So 6, C, and then we always start with 0. So 6C0 is a 1. 6C1 is 6. 6C2 is 15. 6C3 is 20. 6C4 is 15. 6C5 is 6. And 6C6 is a 1. Whenever these two numbers are the same, you always get a 1. And whenever your second number is a 0, you always get a 1 for combinations. So this is helpful for when we want to find a specific term. So let's say we wanted to find the 5th term of a plus b to the 6th. So we already know it because we just did this already. It's 1, 2, 3, 4, 5. So this one right here, which was simplified to this right here. But we can find this out by using combinations. So we know that the first number is always a 6 or whatever your exponent is. And we're using combinations here. The second number here is always going to be 1 less than the term that you're finding. So we're finding the 5th term, so we're going to put a 4 here. Okay, and if you look at this, this is 1, 2, 3, 4, the 5th one that we're finding, and look, it's 6C4. So it's always 1 less than the term you're finding. And then in here, we know we always put the first term, we put the second term. This b is always going to be to the same power. So it's the same with this here. So if you look here, it's always the same. And then these two always have to add up to your 6 or whatever you're expanding it to. So 4 plus 2 is a 6. And that's how we'll get that. So then we just evaluate this. 6c4 is 15. And then we have a squared b to the 4th. So we can try another one where we have to find a specific term here. So let's say we have a plus 3b to the 8th. And we want to find the 6th term. So to find the 6th term, we're going to first use our c here. We know that the first number is 8. And then we know that the next one is going to be 1 less than the term that we're finding. So this will be a 5. So it's 1 less. We'll put our 2 parentheses. Our first term goes here, a, and our second term goes here, 3b. This number is the same as this, 5, and then our exponents have to add up to 8. So this is a 3. And then you just evaluate it. So you go 8c5, you can look on Pascal's triangle, or you can plug it into your calculator, or you can use the formula. So this is a 56. We have an a cubed. And then we have 3 to the 5th is a 243, b to the 5th. And then we just have to multiply our numbers. 56 times 243 to get the entire term. And we get 13,608 a cubed b to the 5th. And this is the 6th term that we just found, if we want to find just a specific term there. Okay, let's do one more where we're going to expand it, and now it's not going to just have a and b in it. So let's say we have 2x squared minus 4 all cubed. So we know that we're going to be using the line in Pascal's triangle that has the 3 as the second number. So if you want to write out all of Pascal's triangle, or just have it referenced, write them all out, and then you could just refer back to that Pascal's triangle. So these are the ones that we're going to be using, because this is the row that has the 3 as your second number. So we're going to be using 1, 3, 3, 1, which means we have 4 terms here. Okay, so we'll write that out. I think it's easier if you just set it up nice and simple here, so that you know what you're filling in. Here's 1 for 1 term, 2, 3, and 4. Okay, so we just said that we're going to be using the numbers 1, 3, 3, 4. 1, 3, 3, 1. And now we'll plug in these numbers. So our first term is a 2x squared, and we know that that always starts with the highest degree. So our highest degree here is a 3, and then we'll decrease for these. 2x squared squared, 2x squared to the first, and 2x squared to the 0. Our second term here is a negative 4, and don't forget about the negative with it. So we have negative 4 to the 0, and then you increase. Negative 4 to the first, negative 4 squared, and negative 4 to the third. And now we'll just clean this up here. So we have 2 cubed. You have to take the 2 and cube that. So 2 cubed is an 8. When you have an exponent inside and outside, you multiply the exponent. So this is 8x to the 6th. And then anything to the 0 is a 1. Okay, so then here we have a 3. We'll just bring that down. 2 squared is a 4. X squared squared, we multiply that as x to the 4th times our negative 4. So we have an 8x to the 6th. 3 times 4 is 12. 12 times a negative 4 a negative 48 x to the 4th. Moving on here, we have 3 times a 2x squared. Negative 4 squared is a 16, because a negative times a negative is a positive. Then we have 16 times 2 is 32. 32 times a 3 is a 96. X squared. And then this one's pretty easy because this will cancel. Anything to the 0 is a 1. And then we have negative 4 to the 3rd is a negative 64. So we'll just bring that down here. And this is using the binomial theorem with expanding our binomial rather than multiplying this out 3 times.